This is SOSF. Alright, check 1 2. We're about to take a hard left turn off the main road of reality. We talk about AI all the time on this channel, right? It's this weird, nebulous thing that's either going to turn us all into super genius gods or paperclips. We live in this crazy, futuristic world where everything is instant, everything is connected. We've got AI that can write poetry and create art, cars that are starting to drive themselves, and supercomputers that are unlocking the secrets of diseases. We take it for granted. We just assume that next year, our phones will be faster, the games will look better, and AI is just going to keep getting smarter. It's like a law of nature, right? Like gravity. But what if it's not? What if this entire thing, this whole technological miracle that we're living in, is balanced on a pinhead? What if the entire foundation of our 21st century civilization has a single point of failure? One tiny spot on the globe that, if it gets knocked over, the whole house of cards comes crashing down. Well, it does, and that spot is an island in the Pacific called Taiwan. This is some wild stuff we're going to get into today. It's not some far-off conspiracy theory. This is based on analyses from think tanks, military war games, and economists. We've put all our eggs in one basket, and that basket is sitting in the middle of the most tense geopolitical flashpoint on the planet. And at the center of this whole story is one company that you all know, a company that has become the engine of the entire AI revolution, NVIDIA. So, let's start there. NVIDIA. These guys are rock stars. Their CEO, Jensen Huang, is this leather jacket-wearing icon who's become one of the most important people in the world. Why? Because they designed these things called GPUs, graphics processing units. They started out making them so your video games would look awesome, so you could get realistic lighting and shadows and all that. But it turns out that the architecture of those chips, the way they're built to handle thousands of calculations all at once, is perfect for artificial intelligence. Training an AI is like trying to teach a baby a language by showing it the entire internet at once. It takes an insane amount of computational power, and NVIDIA's GPUs are the best brains for the job. They control something like 80% of the market for AI chips. So, companies like Google, Microsoft, all the big players, are buying these chips by the truckload, spending billions and billions of dollars to build these massive AI data centers. The entire AI boom that you're seeing right now, all of it is running on NVIDIA's hardware. They are, without exaggeration, building the engine of the future. But here's the catch, and it is the biggest damn catch in the history of business. NVIDIA doesn't actually make any of its own chips. Not a single one. Think of them like a brilliant architect. They design the most incredible, mind-blowing skyscraper the world has ever seen. They have the blueprints, the physics, the materials science all mapped out in their heads and on their computers. They are geniuses at the design. But they don't own a single crane, a single hammer, a single bag of cement. For the actual construction, for the dirty, difficult, insanely complex work of actually building the thing, they send their blueprints to a contractor. And for their most advanced, world-changing chips, they have only one contractor, a company on that little island, the Taiwan Semiconductor Manufacturing Company, or TSMC. This isn't just a casual business relationship. This is a fusion. NVIDIA's business model is not just reliant on TSMC, it is, and the experts use this word, existentially inseparable from it. That means without TSMC, NVIDIA, the multi-trillion-dollar company powering our future, ceases to exist in its current form. It's like its heart is in a vault on the other side of the world. So why? Why this crazy setup? Why not just build their own factories? Because building a state-of-the-art semiconductor factory, what they call a fab, is one of the most expensive and complicated things humanity knows how to do. A single new fab costs upwards of $20 billion. That's more than an aircraft carrier. And it's not just the money, it's the knowledge. TSMC has spent 4 decades perfecting this craft. They have this whole ecosystem, this whole culture of perfection. They have what experts call tacit knowledge, the stuff that isn't written down in a manual, the gut feelings of engineers who have been doing this their whole lives. You can't just buy that. So, NVIDIA made a smart bet. They said, you guys focus on being the best builders in the world, and we'll focus on being the best architects in the world. And it worked. Brilliantly. It's what allowed them to innovate so fast and become the undisputed champions. But in doing so, they created a vulnerability so profound it's hard to even wrap your head around it. Now let's talk about the magic that TSMC does, because this is where it gets really crazy. It's not just that they're good at it, they are the only ones who can do what NVIDIA needs. There are 2 key things here. First is what they call the process node, measured in nanometers. This is basically how small they can etch the microscopic transistors onto the silicon wafer. The smaller you can make them, the more you can cram onto a single chip, and the more powerful and efficient it becomes. We're talking about features that are just a few atoms wide. NVIDIA's latest chips, the ones that are changing the world, are built on TSMC's 4-nanometer process. Nobody else on the planet, not Samsung, not Intel, can match the quality and the sheer scale that TSMC can produce at this level. When your entire company's reputation is built on having the fastest chip, you go to the place that can build the fastest chip. There is no second best. But here's the second part, and this might be even more important. It's a technology called advanced packaging. The most powerful AI chips today, like NVIDIA's H100 or their new Blackwell chip, aren't just one flat piece of silicon anymore. That's old news. They're like 3D skyscrapers. They are literally stacking different chips, the logic chip, the memory chips, on top of each other and connecting them together in this tiny, intricate package. It's a way to get around the physical limits of a single chip. And the key technology that makes this chip stacking possible is called CoWoS, chip on wafer on substrate. It's like the super advanced glue and elevator system for this silicon skyscraper. And guess who has a near total monopoly on CoWoS technology at the scale and quality required? You guessed it, TSMC. NVIDIA's own CEO has said this is the critical piece. Even if another company, say Intel, could manage to build the silicon wafers for them, they couldn't assemble them into the final product. It's like being able to make the world's best engine, but the only company that can build the transmission and put it in the car is 6,000 miles across the ocean. The car doesn't run. NVIDIA has reportedly booked over 70% of TSMC's entire CoWoS capacity for the next year. That tells you everything. There is no plan B. So, we've established the situation. The company that is building the future of AI is completely, 100% dependent on another company located on an island that China considers a rogue province. Virtually all of NVIDIA's most important, highest margin products are made there. Now let's zoom out, because this isn't just about NVIDIA. This is about all of us. For years, people called Taiwan's dominance the Silicon Shield. The theory was that these chips are so important to the global economy, including China's, that it would make a military conflict unthinkable. An attack would be mutual economic suicide. But what was once a shield has now become a choke point. The entire world economy has outsourced the foundation of its technological future to a single, vulnerable place. The numbers are just staggering. Taiwanese factories produce over 60% of the world's semiconductors. Okay, that's a big number. But it gets crazier. When you look at only the most advanced chips, the ones under 10 nanometers that power AI, high-performance computing, and the newest smartphones, Taiwan's global market share is over 90%. Let me say that again. 90%. One single company, TSMC, is responsible for 92% of the production of the most critical components for the modern world. That is not a market share. That is a global monopoly on progress. So, what happens if something goes wrong? What happens if there's a conflict? Not even a full-scale invasion. Let's just say a naval blockade. Ships can't get in or out. The first thing that happens is that NVIDIA's production line for its most important products drops to zero. Not slows down. Not gets delayed. It stops. Overnight. The entire supply chain is instantly decapitated at the source. And there's another spooky detail here. The machines that make these advanced chips, the most complex machines ever built by humans, come from a single company in the Netherlands called ASML. These machines use something called extreme ultraviolet lithography, and they are the key to making sub-7 nanometer chips. Well, reports have come out that these machines are equipped with a remote kill switch. The Dutch and the Americans can shut them down remotely if there's an invasion. It's a failsafe to prevent the technology from falling into the wrong hands. So even if the factories survive the fighting, the machines themselves could be turned into billion-dollar paperweights. The production would be over, permanently. The moment that happens, NVIDIA, the corporate titan, experiences an immediate and total collapse. With no product to sell, its revenue streams just evaporate. Its multi-trillion-dollar market capitalization, which is all based on the promise of future growth from AI, disappears. The story is over. The stock becomes wallpaper. It goes from being the most important company of the future to a design firm with a bunch of brilliant ideas that can never be built. But that's just the first domino. The shockwave from that, the great deceleration as some analysts call it, would be catastrophic for everyone. The first and most obvious victim is the AI revolution itself. Progress in AI is driven by more data, smarter algorithms, and most importantly, more computing power. Without a steady stream of new, faster, more powerful GPUs, the training of next-generation models just stops. The field would enter a long, cold AI winter. Not because we ran out of ideas, but because we ran out of shovels. The big guys, Google, Microsoft, Meta, they'd have their existing server farms, but all the startups, all the university researchers, all the innovation happening at the edges would be frozen out. Progress would grind to a halt. Next, The cloud. The entire digital economy runs on the massive data centers built by Amazon Web Services, Microsoft Azure, and Google Cloud. Their main growth engine right now is offering AI services, and they are in a desperate arms race to buy as many NVIDIA GPUs as they can get their hands on. Even now, with the factories running at full tilt, there's a GPU shortage. Companies wait for months to get access to these chips. A conflict would turn that shortage into a famine. The multi-billion-dollar expansion plans of the cloud giants would stop cold. And that means the thousands of businesses that rely on them for everything from hosting websites to running their own AI applications would be throttled. The engine of the digital world would seize up. Then you've got the car industry. The whole future of cars is about turning them into software-defined, high-performance computers on wheels. This is what enables advanced driver assistance, and eventually, true self-driving. NVIDIA is at the heart of this with its Drive Thor platform, a superchip designed to be the central brain for these intelligent vehicles. Major car makers have already designed their next generation of cars around this chip, with the first one supposed to roll out next year. If the supply chain breaks, those plans are completely derailed. The dream of autonomous cars gets pushed back by a decade, maybe more. The auto industry gets plunged into a crisis that would make the previous chip shortages look like a joke. And it just keeps going. High-end consumer electronics? Your next smartphone? Your next laptop? Severely impacted. Scientific research? Supercomputers used for climate modeling, for discovering new medicines, for sequencing genomes? They can't be upgraded. Progress stalls. Every single corner of the economy that uses advanced computing to get better, faster, and smarter would suffer. This isn't a tech sector problem. It's a global economic heart attack. The economic models are just terrifying. One conservative estimate from the Rhodium Group says a blockade would immediately put over $2 trillion in global economic activity at risk. They figure that companies that depend on these chips could lose as much as $1.6 trillion in revenue in a year. Bloomberg Economics ran their own model and came up with an even scarier number. A conflict could wipe $5 trillion off the global economy in the first year alone. That's a 5% contraction in global GDP. To put that in perspective, the 2008 global financial crisis caused a drop of about 5.9%. So we are talking about a shock on the same scale as the worst financial crisis of our lifetimes. The financial markets would go into a freefall. Global trade would seize up because the banks that finance everything would pull back in the face of such massive risk. We wouldn't just have shortages of electronics. We'd have shortages of everything, because the whole logistics network that moves goods around the world would break down. So, what do our leaders do? What's the response from the US government? Well, the RAND Corporation, a major military think tank, ran a war game on this exact scenario with senior government and industry officials. Their conclusion was blunt and terrifying. In every scenario, the United States faces unfavorable outcomes and has only bad options. Think about the dilemma. Option 1. You give in to an aggressor to avoid the economic catastrophe. You basically sacrifice Taiwan and accept a new world order. Strategic capitulation. Option 2. You resist. You send in the military, you impose severe sanctions. But the war game concluded that this would lead to broad and lengthy economic turbulence that would be politically unsustainable. Imagine a deep global recession, mass unemployment, shortages of critical goods. The pressure on our own government would be immense. It might be impossible to keep up the fight. The core of the problem is that our economic fate is so tied to that one island that our ability to act is crippled. We've walked into a strategic trap of our own making. Okay, so people are waking up to this, right? The government must be doing something. And they are. You've probably heard of the CHIPS Act. The US and the EU are throwing hundreds of billions of dollars in subsidies to try and bring chip manufacturing back home, to reshore it. The goal is to triple US domestic chip-making capacity by 2032. Intel is building massive new fabs in Arizona and Ohio. Samsung is building in Texas. This is all good. It's necessary. But there's a fatal flaw in the plan. The timeline. All of these initiatives are aimed at 2030 and beyond. They are a long-term solution to a problem that could become a crisis tomorrow morning. It's like starting to build a fire station when your house is already on fire. And there's an even bigger, more specific problem that shows a fundamental misunderstanding of the real bottleneck. It goes back to that advanced packaging, the CoWoS technology. The flagship project of the US CHIPS Act is the new TSMC fab being built in Arizona. It's costing tens of billions of dollars. And it will, eventually, make advanced silicon wafers on US soil. Great. But the current plan is for that fab to not have the advanced CoWoS packaging line. That capability will remain exclusively in Taiwan. So, get this, to make a state-of-the-art AI chip, the process would be to fabricate the wafer in Arizona, then ship it 6,000 miles across the Pacific to Taiwan for the final assembly. and then ship the finished chip all the way back. Think about how insane that is in a conflict scenario. A naval blockade happens, and that brand new, multi-billion-dollar Arizona factory is rendered completely useless for making the world's most important chips. The supply chain is still broken. The massive investment in resilience would have failed its most important test. It's a fatal flaw in the strategy. For the foreseeable future, there is simply no substitute for Taiwan. So, let's step back and think about what this all means for us, for humanity. This goes beyond economics and geopolitics. For our entire lives, we've lived in an age of exponential progress, defined by Moore's law, where computers just keep getting better and better. We assume this is the natural order of things. A conflict over Taiwan would bring that era to a violent, screeching halt. We would be locked into the technology of the mid-2020s for a decade or more. That's how long it would take to even begin to replicate Taiwan's entire ecosystem somewhere else. The engine of progress would stall. Think about what that means. Progress in medicine? In developing new life-saving drugs? Slowed down. Our ability to tackle huge problems like climate change using massive computer simulations? Constrained? Safer transportation? Cleaner energy? A more connected world? All of it gets put on hold. In the most extreme scenario, some people worry about a kind of technological dark age, a time when we still know how to design incredible things, but we've lost the physical means to produce them. It would redefine global power. The country that could rebuild this capability first would have an almost insurmountable advantage over everyone else. The new great power struggle wouldn't be over oil or land, it would be over control of computational capacity. So, here we are. We have built a modern world that is capable of incredible wonders, but we've built it on a foundation of sand. We've chased efficiency and low cost for so long that we forgot about resilience. We've created a masterpiece of globalized supply chains that is also a single, fragile thread. And that thread is stretched taut over the most dangerous place on Earth. It's a sobering thought, isn't it? That the very trajectory of our future, the continuation of the progress we've come to see as our birthright, depends on the peaceful continuation of the status quo in a tiny strait of water halfway around the world. And that really makes you wonder, if we could build something so critical, so fundamental to our entire way of life, and leave it so terrifyingly vulnerable without most of us even realizing it, what else is out there? What is the next single point of failure we haven't seen yet? See you next time.